Welcome to today's lesson on scientific notation, also known as exponential notation. As you can see, this is going to be a tool where we can write very large numbers into a smaller format. The idea is to move the decimal point so that the number is between 1 and 10. Okay, you could see in this example right here in the middle that you have here a 6 here followed by, I believe, 23 zeros. And if we were to change this to scientific notation or exponential notation, what we want to do is we want to move the decimal point. And right now on this number, the decimal point, if you can see here, it's at the end over here. We want to move it, and usually the idea is to put it right behind the first non-zero digit, which would be right here behind the 6. Okay? If you put the number there, the number would become 6.0. And that number fits the description that in this new format that number will be between the numbers 1 and 10. Had I placed the decimal point before the 6, this number would be less than 1, which would not fit our format. Had I placed it after the first 0, it would have been above 10. Again, neither one of these two would have fit our description. So by placing it after the 6, 6.0 is obviously between 1 and 10. Now, if you look at and count the zeros, in order for me to move it to this position over here, I needed to move the decimal point 23 spaces. You can see me count here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, and 23. So notice that since I moved it 23 spaces to the left, that becomes the exponent. And notice how the exponent is positive. At the end of the lesson, I'll do a summary. But notice when I move the decimal point to the left, like I did in this number, the exponent happens to be a positive number, in this case 23. In our next example, notice that this time we want to move the decimal point to the right. In fact, in order to fulfill this trend here, where the number has to be between 1 and 10, that means that the decimal point would have to be moved after the number 2. Again, if we move it before the number 2, that number would not be between 1 and 10. So by moving the decimal point after the 2, we fulfill that portion of our rule. Now, how many spaces does it take to get there? Well, again, if you count, it's going to be 23 spaces again. I'll show you. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, and 23. However, we moved the decimal point this time to the right. In the previous example, we had moved the decimal point to the left. This time we moved it to the right. So the difference is that instead of putting a positive exponent, we're going to use a negative. So instead of being to the positive 23, this time it's going to be to the negative 23. Again, I will summarize this towards the end of the lesson. Let's take a look here. So here's another example. The 2013 U.S. population was estimated to be 315 million people. Express this in scientific notation. So the goal here is we want to make the number between a 1 and a 10. In order to do that, the decimal point right now is at the end of the number. We want to move it between the 1 and the 3. By placing the decimal between the 3 and the 1, it will now be, as you can see, this number will be between a 1 and a 10, which is our rule. Okay? So that's where we want to move the decimal point. Now the question is, how many spaces will it take to get there? Well, the decimal point is at the end of the number, so we're going to go 1, 2, 3, 4, 5, 6, 7, 8. This time we're going to move this this decimal point 8 spaces to the left. Again, when you move the decimal point to the left, you're going to see that the exponent is going to be positive. So we moved it 8 spaces. So what we're going to do is we're going to put 3.15. This is the location of the new decimal point position. And then we're going to put times 10 to the 8, and it'll be a positive number. Let's take a look at another example. This time, here's a skill builder for you to do. Express this number in scientific notation. Okay, pause the video, and I'll give you a minute to try this. Okay, hopefully you got the answer already. So in order to fulfill our rule, the decimal point is at the back. We want to move it so that the number is between a 1 and a 10. That means we're going to move the decimal point right over here between the 1 and the 6. The number is going to become 1.6, and then you put the rest of the numbers 1.6342. Now, how many spaces did it take to get there? We're going again to the left. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 spaces. Again, we moved it to the left, so the exponent will be a positive 13. Let me fix that. Okay, so it'll be 1.6342 times 10 to the 13. Let's try another example. It says the radius of carbon atom is approximately 0.0000000070. A lot of zeros. We want to move this or express this in scientific notation. This time, we want to move the decimal point to the right. Again, we want to move it so that the number is between a 1 and a 10. That means that the decimal point will be moved so that the number is 7.0. We want the decimal point to be behind the 7. 7.0 does fulfill our rule. It's between a 1 and a 10. The question is, how many spots are we going to have to move this decimal point? Now, again, we're going to the right. So if you look at this, you go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's going to be times 10 to the 11. However, because we moved it to the right, we're going to put a negative exponent. So it'll be times 10 to the negative 11. Here's a Skill Builder 2.0. Let's express this number in scientific notation. Again, I'll pause for a moment so you can try it. Okay, hopefully you are back. And what you're going to do here is, in order to fulfill our rule, we want to put the number so that it's between the 3 and the 8. By placing the decimal point there, 3.8 is between a 1 and a 10. Now, how many spots did it take us to get there? Well, let's see. 1, 2, 3, 4, 5. Now, we did move it to the right. So, yes, the exponent is going to be a 5, but because we went to the right, it'll be a negative 5. So the answer is 3.8 times 10 to the negative 5. Okay? Now, let's do this. I'm going to do a summary. If you have a number in long form, and you want to change it to, I'll abbreviate here, scientific notation. I'll just make up a number here. Let's say I had 2, 8, 4, 0, 0, 0, 0, 0, 0. Okay? And I wanted to change this to scientific notation. Notice, in this example, I am moving the decimal point to the left. I'm over here. Okay? So if I go 1, 2, 3, 4, 5, 6, 7, 8, my answer is going to end up being 2.84. Okay, I moved it 8 spaces, and it's going to be to the 8. So I'm going to write a little rule for you. Okay, and I'm going to be abbreviating. So when you're going from long form to scientific notation, if you move, and I'm going to abbreviate here, if you move the decimal point to the left, which is what we did here, then the exponent, and I'll abbreviate, the exponent is going to be positive. Notice it's a positive 8. So when you move the decimal point to the left, the exponent will be positive. Now, let's do the following. Let's do the same thing, again from long form to scientific notation. This time I'm going to write a different number. Okay, so again, to fulfill our rule, we want to move the decimal point so that the number's between a 1 and a 10. We want to move it, in this example, to the right. So we want to go 1, 2, 3, 4, 5, 6, 7 spots. Our new number is going to be 7.25 times 10. And notice it's going to be to the negative 7. The rule in this example is, when you're going from long form to scientific notation, if you move the decimal point, again I'm abbreviating, and this time we moved it, notice, to the right, then notice the exponent, and I'll abbreviate over here, is going to be negative. So the answer to this one is 7.25 times 10 to the negative 7. Okay? Now, let's do the following. Let's go backwards. Let's say I have something in scientific notation, and I want to change it to the long form. You might have to do this from time to time. So let's say I had 1.85 times 10 to the 5th. So notice that the exponent is positive. What you're going to do here is, and I'll write the rule at the end, when the exponent is positive, what you're going to do is you're going to move the decimal point to the right. Okay? So we're going to move the decimal point to the right 5 spots. 1, 2, 3, 4, 5. And what you're going to do is you're going to fill these in with zeros. So our new answer is going to be 185. And here are the zeros you filled in. You could put a comma there if you want. Now notice when we're going backwards, here's the rule. If the exponent, okay, again I'm abbreviating, is positive, then, notice what we did, then move the decimal point to the right. And that is what we did in this example. Okay? And I'll give you one final rule here. Again, let's say we're going from scientific notation to long form. This time, let me come up with a number here. Let's say I have 6.12 times 10 to the negative 4. Now, notice the exponent is negative. What you're going to see is that when the exponent is negative, we're going to need to move the decimal point to the left. In this example, we're going to go left 4 times. So you got 6.12 here. And what we're going to do is we're going to go 1, 2, 3, 4. You're going to fill that in with zeros. And your answer is going to look like this. Here are the zeros you filled in. And then you got that. If you want to put a 0 here, that's fine. Okay? But notice you have to fill in the zeros. And the answer is 0.000612. So let's follow this up with a rule. So when you're going from scientific notation to long form, and you see, okay, if the exponent, okay, again abbreviating, is negative, as in this example, then what we're going to do is then move the decimal point, and notice what we did, move the decimal point to the left. And there's your answer. Okay? So the last part of this lesson was giving you a summary and with these rules written out so that you know what to do, whether you're going from scientific notation to long form or vice versa. Okay?